All right, so on example 1, you ready? We're going to identify zeros of polynomials when suitable factorization is available. Now this one, example 1, is easy because it's already factored. This one's already factored. It is. It's already factored. So it's pretty easy. So if we're finding zeros, if we're going to find zeros, we set it equal to 0. So 0 is equal to x minus 2, x minus 3, and x plus 4, okay? I mean, it's already factored for us, so it's really going to be super easy. In fact, yes, I'm taking the long way to get the answer, but I mean, you could probably say, well, yeah, I'm going to use the answer is 2, 3, and negative 4. You see it? 2, 3, and negative 4, right? So if I just go, I'm going to show every step. So if I take 0 equals x minus 2, and 0 equals x minus 3, and 0 equals x plus 4, right? I'm showing every step, but I know, Ryan, by now you've already got the answers a long time ago, and I'm putting you to sleep, aren't I?
Got the answers to the next one.
Yeah, I believe it. X equals 2, x equals 3, and x equals negative 4, right? So if I graphed these, the zeros are also x-intercepts. In fact, they're going to see three words that are going to be synonymous. We're going to see zeros. We're going to call them x-intercepts. And we're going to call them things called roots. Now roots, I'm going to put a question mark, because roots aren't always going to be x-intercepts. We're going to talk about that another day when we start talking about imaginary numbers. But for right now, put these three words, zeros, x-intercepts, and roots, mean the same thing. So on this one, if I were to graph it, the graph would have passed through 2, the graph would have passed through 3, and it would have passed through the x-axis at negative 4, right? And the graph would look something like this. And you can put it on your calculator if you don't believe me, but it really does look something like this, right? And we talked about that yesterday, right? And behavior, it's going to go off to infinity, okay? All right, now, example 2. I want you to do it by factoring. By factoring. Okay, yeah, there's other ways to do it, but let's do it by factoring. If it factors, for me, it's faster to do it by factoring, so set it equal to 0, right? 0 equals x cubed minus 2x squared minus 8x. Now, Devin, you asked a really good question about 10 minutes ago, maybe 5 minutes ago. You said, well, Mr. Davis, what if you can take something out of all three terms before you do that? In fact, you're right. In this case, I'm going to common factor first. Okay, they all have a common x, don't they? So I'm going to common factor before I do the other factoring. So I'll common factor out an x, because they all have an x term in common. Okay. If I common factor out that x, I'll have an x squared minus a 2x minus an 8. Okay. By the way, I know there's going to be 3 answers. There has to be 3 answers. How do I know there's going to be 3 answers? It's cubed. Who said that? Nice job, Colby. That's right. If it's an x cubed, it's going to have 3 answers. Right? Now, can I factor this again? Sure. You guys know how to factor. We actually did this when we were doing a little bit of factoring today. So how would I factor x squared minus 2x minus 8? X minus 4, x plus 2. Of course, the answer is going to be the opposites because we're going to set them equal to 0 and solve it. So really what we have are 3 factors. These are 3 factors. Let's find out when they equal 0. So one is x equals 0. The other is 0 equals x minus 4. And the other is 0 equals x plus 2, right? So you set all 3 factors equal to 0 to find out when they're equal to 0, right? So I put all 3 factors equal to 0. So one answer is easy, x equals 0, right? And that makes sense. Because if I were to put 0 back in for x, guess what? If I put 0 back in for x, it would be 0, right? You could see that. Plus 4, the other one is a positive 4. There's my other 0. Minus 2, the other one's a negative 2. Okay, there's my 3 zeros, okay? Now, sometimes they don't factor. So what do? Well, let's use technology, okay? I mean zeros, right? We've got a button on how to find zeros on our calculator. So on this one, we're going to use our calculator. So we're going to go calculator. We're going to graph. And we're going to look for zeros, right? Let's see how that works. So do we see that? Okay, wait, let's go. Okay. So I'm going to go to my y equals. I'm going to go a 3 x to the 4th plus 4x to the 3rd, subtract 7x squared minus 2x, subtract 3, okay? Now my window, I'm probably going to just, here's an easy window. I'm going to teach you an easy one. If you go to zoom, if you hit zoom, they've got a standard window, okay? Standard window means negative 10 to 10, negative 10 to 10. So instead of me going back into my window and typing in negative 10 for x min, 10 for x max, negative 10 for y min, 10 for y max, right? If I go to zoom, my zoom button, and I hit 6 for standard, it's just automatically going to change it to a standard window, okay? Boom. Now if it's not from there a good enough window, I can always change it again, but you know, I don't see all of the graph, but I don't need all the graph. What do I need? What do I need? I need the zeros, so I need that and that, so it's got 2 zeros, right? Technically it does have 4, but the other 2 will be imaginary, and we're going to talk about that tomorrow, all right? So let's just find the ones, the real zeros. So if I go to my calculate, my 0, I'm going to go to my left bound. So if I go to the left bound, and use your back and forth arrows, you guys, don't use your up and down. Don't use up and down. So even though my cursor is blinking above it, you see that? It's still to the left-hand side of it, correct? Still the left-hand side of it. So I lock it, push enter. Now I'll bring my cursor right about there. Even though it's below it, it's still on the right-hand side of it. Does that make sense? Lock it in, guess. Okay, so one of my zeros is about negative 2.3, okay? So it's about a negative 2.3, comma 0, or x equals a negative 2.3. And then the other one is over here by 1, so we'll do the same thing. We'll calculate my zeros. Take the cursor all the way over here. Okay, left bound's got to be below it. Does that make sense? Even though I'm below it, I'm still the left of the 0. Okay, lock it in. God bless you. Okay, the cursor's above my 0, but remember, we're looking for whether it's on the right-hand side, and yes, it's on the right-hand side. Don't weird out the fact that it's above or below it. It is on the right-hand side. Enter. So now I've told my calculator, look in this little space right here for the 0, it will, and it finds it at about a 1.3, okay? So you get a 1.3, comma 0, or x equals a 1.30, okay? Not too bad. Now, it does have 2 more zeros. The other 2 are imaginary. We'll use I. So we're going to talk about I tomorrow and about imaginaries, because you will get 4 answers. And when you get 4 answers, the other 2 are going to be I's. That's when we start to talk about the difference between a root and x-intercepts. Roots can be imaginaries and reals. They'll still be zeros. Okay? If they're imaginary, they won't be x-intercepts. Okay? Because this graph has got 4 answers, but only 2 of them are real. Want to turn the page? All right. My favorite button, the poly button. Okay, now these calculators are so cool. It has a thing called the poly button. What does the poly button do? It finds zeros. Okay, where do you find the poly button? Everybody have a calculator? Do you need to take a minute to get a fancy calculator? If you do not have a good calculator, you might want to grab one, okay? Okay, if you don't have a good calculator, you might want to grab a calculator, okay? Now, how many kids love the quadratic formula? You guys love the remember minus b plus no hands?
No.
Nobody likes negative b plus minus squared b squared?
Got me out of factoring every
Minus 4ac all over 2a. Well, I mean, these calculators, wouldn't you think that they could do the quadratic formula? Wouldn't you think so?
Yeah, but they can't.
Of course they can. You just have to know where to look. I have just kept this a secret from you for all those years, haven't I? Of course these calculators do it. So where do you find it? Okay. So first, you've got to go to apps. Okay. Got to go to apps. So go to apps. Okay. I'm going to go to apps. Apps happen to be like a purple button right above the sign. So apps, my apps button is right there. So go to apps, and hopefully you have a lot of stuff in your calculator under apps. If you don't have the poly button, then I'll give it to you later, okay? Now, yeah. So then I'm going to find it. So I'm looking for this poly thing. So let me just go down. I'm looking for it's in alphabetical order. Yep, you found the right one, Quinn. You're ahead of me. I like that. Element. Oh, there it is. Polysmilt. Everybody find it? Okay.
Smelts too.
Everybody find it? Oh, if you have Smilt 2, that's fine. You have a newer calculator, right? Yeah, if you have so some of your calculators are going to be quite a bit newer than this. This is just the old version. Enter. Everybody good? Right? Everybody enter. Enter. Free advertisement. Don't you love free advertisement? Yes, Texas Instrument. Okay. So enter. Now, we want to go to Polyroot Finder. Polyroot. Isn't that what we're trying to find? Is the root? Polyroot Finder. We're finding the roots. Okay. Enter. Now, degree. What's the degree of this polynomial?
2,
9, 6, 14,
5.
8.
5. I know I was gone when I taught this, but I did teach it on film, right? The degree is always the biggest exponent, right? I did talk about that one day. So the degree is 5, okay? So put 5. Now, what it is doing already is it's letting the calculator know that I'm going to have to put all of these coefficients in. It also knows there's going to be 5 answers, right? So I push enter. Okay, now, A5, which is the first coefficient. So I'm going to put the 2. A4, which is the next coefficient. 5. Now, if you're missing a term, put in 0. Does that make sense? If you're missing a term, put in 0, okay? -8. -14. 6, and then 9, right? Now you're going to go to solve, which is over here by the graph button, right? Everybody see that? I'm going to hit solve. Just push the graph. Push that button right there, solve. Now it's thinking. It's thinking. It's finding them. It doesn't actually do the math.
Like low to the top right.
It just finds them. Now it hasn't found them yet. It's still thinking.
Wait, how did you get from the polyroot finder mode to like that?
Okay, hold on. Let me finish up. I'll show you, okay? So, what I have is 1. I've got -1 point. Now remember, here's what the calculator does not do math. It tries to find them. It tries to find them. So these answers aren't exactly accurate, but we're going to make them accurate. In fact, 1 is right. This is -1. It is exactly -1. I can prove it to you. This is exactly -1 again. It's a double root. Ooh, we talked about double roots yesterday. 1.5 and -3. So my 3 roots are at x equals 1, x equals -1, x equals -1 again, double root, right? X equals 1.5, and x equals -3. Okay, now do you want me to go back through it with you, Nikolai?
Yeah, because I
Okay.
get stuck like after you go to polyroot finder mode and the order thing.
Right. So yours is going to be a little bit different because you've got a newer calculator, right?
Yeah.
So you're going to go to 5, and you're going to go all the way to next.
Oh, next. Okay.
These ones are both like one of the double.
Is it always 5 or oh no, it's because of the match?
Right.
There's some time to work on our rockets today, Davey.
I think we'll have time. So let's take a look at it. Okay, now graph this. We've got now graph it. Now, what I know about this graph is that this is a double root. You guys agree? That's a double root. So let me put in -1, -3. Okay, I'm going to graph it right now in this little space right here. I'm going to have a 1. I'm going to have a 2. So 1.5 is right about there. Okay, everybody see what I've got? Okay, so I have a root or a 0. I have a 0 at 1. I have a double.
So it's going to bounce.
Yep, it's going to bounce. It's going to bounce at -1, totally right. I'm going to have a 0 at -3, and I'm going to have 0 at 1.5, okay? Now, end behavior, that's a positive 2x to the 5th, right? End behavior. So I know at the very last root, it's going to go up.
Wait, how do you know that again?
Great. This is a positive 2x. So the leading coefficient is positive, then at the very end, it's going to take off to positive infinity. Just like Ryan. If this were a negative, I would have drawn it going down. Ryan, question?
So when I plugged it into the calculator, it's kind of normally and found the zeros.
Yeah.
It said -.99999.
Right. And you know what? I can do a little bit of real math and I can prove to you it's negative 1, okay? Yeah, if I do a little calculus, but, you know, I can prove it. But anyway, actually, you know, another way you can do is plug in negative 1 and you'll get 0. That's another way to prove it. Does that make sense? That's the easiest way to prove it, Ryan. Okay, let me go ahead and do this. So I'm going to come down through, I got to come back through that one, right? I got to come back through with that one, right? Because it's a 0. Now, when I get to my double root, we're going to bounce. That's what Simon says, right? Because it's going to go through negative 1 and then back through it again. I like the way it bounce. Never heard, I always say touch and go is what I use. Bounce is good. Bounce, boing. And it's going to go back through negative 3. So if you graph it on your calculator, it should look like this. Ryan, did you graph it?
Yes.
It looks, I bet it looks like that, doesn't it? Okay.
Not as nice curves.
Well, you know, yeah. I didn't put the heights in, did I? You don't need the heights. I just need the general shape, okay? Okay, so homework today. We got page 283, 15, 27, 55, 61, 95, 99, and we have, well, let's get it done, and we'll talk about the rockets later.